Greetings to all. My name is Robert ADAIKALARAJ and I am going to explain about trees in data structure. First of all, we must know what is a data structure that we have already seen in the data sections In this section, we are going to see about trees. Before entering into the trees, we must know what is the difference between a linear data structure and a non-linear data structure. When we consider a linear data structure, the examples are arrays. You can clearly note over here that is an array is data are stored in a sequential format. For example, when you consider an array, A is stored in 100 and B is stored in 1001, and like on it goes in a sequential format. Similarly, a linked list. Here also the data will be stored one after the other, but it will not be stored in a continuous memory location, that we know that. So this is called a sequential way of storing data. When we come to a non-linear data structure, that is, the data will not be stored in a sequential pattern. Rather, when you consider a tree over here the data are not stored in a continuous pattern, but it follows some methodology for storing a data. Similarly, we can see a graph. This is a graph, and this graph is in this graph also the data are stored, but it is not in a sequential pattern. So in this section, we are going to see a small introduction about tree. Right. A tree. This is a data structure of hierarchical pattern. When we go for an hierarchical pattern, we can remember our family. Our great grandfather followed, he will be in the first hierarchy. After that, you will be having your grandfather in the second hierarchy. After that, your father. After that, yourself, and after that, your children. This is called as hierarchical data structure. When we consider here, I have given you a map like this. In this hierarchical data structure, you can see a managing director at the topmost level. After that, we are having managers, and followed by them we are having assistant managers, and followed by them they are having supervisors, and so on. So this will be the hierarchy which is followed in a company. Using this hierarchical structure, I am going to store a data. So this is called as tree data structure. This tree data will be arranged in a hierarchical data structure. So we will see some terminologies of tree. Before entering into the tree, we must know what this round is. This round is actually where the data is stored. This is called as a node. The round pattern which is displayed over here is called as a node. So in each node, the values will be stored. The value will be stored in a node. So we can keep it in a mind like this. The values are stored in a mind. Then the link between the two nodes, here I am having node 1 and here I am having node 2. There exists a link between node 1 and node 2. That is a line connection. You can say in any way. Link, you can say in any way. Right. This link is called as edges. This is the basic things which you must know. The round thing which here is said to be as a node, and the thing which is connecting each other, the link which is connecting each other, is said to be the edges. In a tree data structure, there are n nodes. If you consider that I am having n number of nodes in the sense, in this tree you can consider here how many nodes are there. 1, 2, 3, 4, 5. Here I am having 5 nodes, and each 5 nodes are connected some way to other. Then you can find how many edges are there. The connection, the link is 1, 2, 3, 4. This is the point which is described in the third point. That is, n nodes can have n minus 1 links. So if we have n nodes, then the edges will be n minus 1. Here I have 5 nodes, so here then there will be only 4 edges. 1, 2, 3, 4. This is called as nodes and edges. Now, which is said to be the root node? The root node is the topmost node. Root node is one of the term which will be used in a tree. Which is said to be a root node? The root node is the topmost node of a tree. There will be only one root node. That is also you have to keep in mind. There will be one root node. From this root node, they will be having, they will be diverted to many nodes. So a root node. What is a root node? The topmost node of the tree is called as a root node. Then parent node. What is a parent node? The predecessor node. Here consider D, E, F. For D, E, F, the predecessor node. Predecessor in the sense the above node. D, E, F, the above node is B. So the parent of D, E, F is B. See, for B and C have same parent, that is called A. Here K has a parent called G. Similarly, G and H is have a parent called C. So the predecessor node, predecessor in the sense the above node, which is connected to that particular node, is called as its parent. This is a parent node. Similarly, you must know what is a child node. The successor node. If B, from B I have some successor. Say from B I am at the next level, I am having D, E and F, which are connected to this B node. Then these nodes are said to be the children of B. So B have 3 children. Similarly, there may be nodes without children. See I, this I node does not have any children. This J node does not have any child. Similarly, the H node does not have any child. These nodes, I will say in later, these nodes is called as leaf nodes. Okay. Now, siblings. Which nodes are said to be siblings? In a simple way, we can say children of same parents are called siblings. D, E, F are the children of B. So, D, E, F are considered to be siblings. B and C are siblings because they have a same parent called A. Right? I think you are clear with siblings. Leaf node. In the leaf node, in the sense, the node without any child is called leaf node. Here consider this one. D node does not have any child. F node does not have any child. H node does not have any child. K node does not have any child. I node does not have any child. J node does not have any child. So these nodes are said to be leaf nodes or external nodes. If there is an external node, similarly there will be an internal node. What is the internal node? Any node which has at least one child, then it is called as an internal node. See, A has 2 children, no problem. The thing what here, the thing said over here is a node which have at least one child. A have 2 childs. See, G have only one child, so this is also an internal node. So any node which have a child, then it is called as an internal node. So what is an external node? Any node without children or without a child is called a external node or a leaf node. They commonly say this node as a leaf node. Level. How to make the level of a node? Level of a node is calculated by putting the root node to level 0. Level 0. You have to put the root node to level 0. Then their children will be at level 1. Then after this, their grandchildren will be at level 3. Then at the level 4, these grandchildren will be at level 4. So you have to put 0 for root node and you have to proceed plus 1 to the successor nodes. So this is said to be level. This is how you have to find a level of a node. If somebody asks you what is the level of E, then we have to say the level of the E node is 2. So this is how we have to calculate the level of a node. Subtrees. What is a subtree? A subtree is a child of a node. We can consider over here, it is not a child followed by everything. See, in simple I can say, if this A have 2 children, so B and C. If you remove this link, this B will be considered to be a separate tree. So if see, I am again saying A has two children, so two links are there existing. One link lead you to B, the other link will lead you to C. If you remove this link, this will become a separate tree and this will become a separate tree. So this is said to be subtrees. So this is said, B is said to be one subtree and C is said to be one subtree. Similarly, if you remove the link which is from B to E, then EIJ will be another subtree, right? So how to calculate a subtree? How to see a subtree which is said to be a subtree? A subtree is a subset of large tree. We are having a large tree. Their subsets are said to be subtrees. Path. So what is a path? The path is the link. We have to go through the link from the root node to that particular node. Any node you can go. For example, if you consider the path to F, then I have a path over here like this. A to B, B to F. This is the path. Now here the path is already defined. Here the path between A and J. J is over here. So A, B, E, J is said to be the path for that particular node. Any node, if you want to find the path, you have to start from the root node. Here the root node is A. So we have to start from the node. Right. Similarly, if they are asking for a path between C to K, then we have to start from C. C, G, K. This is the path. Right. So we have to find the path in this pattern. Number of edges. How to find the number of edges? Simple. The number of edges in the sense connection of nodes. If it has n nodes, then it will be n minus 1 edges. This we have already seen over there. This is called as edges. When we start this session, I told you about these edges. Depth. How to find the depth of a node? How to find the depth of a node? The depth of the node is defined as the length of the path from the root node to that particular node. See, this is going to be the root node. This node is having a link to B and C. So these links are said to be at 1. Right? Now, if I am going to find the depth of E, so what is the depth of E? The depth of E is going to be, then we can say another number of edges you pass away. From A to B, you pass from one edges. From B to E, you will be having another edge. So we are having two edges. So the depth of E is 2. Here the depth, sometimes they will be asking the depth of the tree. How will you find the depth of the tree? The maximum depth is said to be the depth of the tree. Say 3, 3, 3. So any 3 you can consider. The maximum depth is said to be the depth of a tree. If it is going to be a depth of a node G, if I am going to find the depth of the node G, then the depth is 2. So I have to pass through 2 edges. If I am going to find the depth of C, then it has a depth 1. If I am going to find the depth of A, I have no edges, then the depth is said to be at 0. Height. Similarly, height of a node. You are calculating the depth from the root to the node. Height of a node you have to calculate from the bottom to the top. Here, the height of the node, height of G is said to be 1. The height of C is said to be 2. The height of A is said to be at 3. So what is the height of a tree? The maximum height you go is said to be the height of the tree. Here what is the maximum height? 3. So the maximum height of the we travel is said to be the height of a tree. This you have to keep in mind. If you are going to find the depth, you have to start from the root node. If you are going to find the height, you have to start from the leaf node. Thank you.